Namaskar. Today we'll study sulfonamides. Sulfonamides are structural analog of para-amino benzoic acid. Sulfonamides are basically antibacterial drugs. They inhibit folic acid synthesis. How they inhibit folic acid synthesis? In folic acid synthesis, we require para-amino benzoic acid. Since sulfonamides are structural analogs of para-amino benzoic acid, sulfonamides competitively inhibit PABA and hence inhibit folic acid synthesis, and there will be no production of tetrahydrofolic acid. This folic acid we can obtain from diet, but bacteria has to synthesize folic acid. It cannot obtain from diet. So it has to synthesize. So sulfonamides have selective action in bacteria and not harmful to us. Then how this folic acid synthesis occurs? From guanine there is production of dihydropteridine diphosphate, which in presence of PABA and dihydropteroate synthetase forms dihydropteroic acid or dihydropteroate, which is again in presence of glutamic acid and folate synthetase produces steroyl glutamic acid or folic acid. This folic acid undergoes reduction twice, once to dihydrofolic acid, then to tetrahydrofolic acid by the enzyme folate reductase or dihydrofolate reductase. Both enzymes are same. Nomenclature is different because the substrate is different. Then tetrahydrofolic acid acts as the coenzyme to thymidylate synthetase, which is required for the conversion of deoxyuridine monophosphate to deoxythymidine monophosphate. Deoxythymidine monophosphate helps in DNA synthesis and hence is required for bacterial growth. So sulfonamides, by acting as competitive inhibitor of PABA, inhibits bacterial growth and act as bacteriostatic. But these sulfonamides are ineffective after the pause formation. Why? Because sulfonamides are competitive inhibitors. So competitive inhibitors, they are competitive inhibitors, and because that means there will be competition between sulfonamides and PABA, and POS contains a large quantity of PABA. Since POS contains a large quantity of PABA, so in the competition PABA will be more, and PABA will be there, and there will be folic acid synthesis instead of sulfonamides binding. So in presence of POS, sulfonamides become ineffective. Then so we can classify the sulfonamides as systemically used and locally used. Systemically used, again based on the duration of action, we can classify them as short acting, intermediate acting and long acting. Short acting sulfamerazine, sulfadiazine, sulfadiamidine, sulfafurazole, sulfacetamide. Intermediate acting sulfamethoxazole. Long acting sulfadoxine, sulfamethoxine, sulfadimethoxine. And those which are poorly absorbed, systemically used, they are usually having good absorption, and those sulfonamides which are poorly absorbed, they are used locally or topically. For example, silver sulfadiazine, sulfaguanidine, succinyl sulfathiazole, thallyl sulfathiazole. So this is the classification of sulfonamides. Now if we discuss the pharmacokinetics, two major points are there. First point, the metabolite, sulfonamides are metabolized by acetylation, and the acetylated metabolites are less soluble, so they get precipitated and form crystals, and the condition we call as crystalluria. And this crystalluria can be prevented by use of sodium bicarbonate, which will alkalize the urine, and it will become soluble and can be excreted. Or we can take plenty of water to excrete that, or we can use highly soluble acetylated product, the sulfonamides having highly soluble acetylated metabolites, for example sulfafurazole. And the second point in pharmacokinetics which we must know, that sulfonamides are highly plasma protein bound. So we know plasma protein binding, a drug binds to a plasma protein and forms an inert or inactive complex, and this is a reversible complex. So again it can dissociate to release the free drug. So this is the bound drug with protein, and this is the free drug, and drug is active in its free form, inactive in the bound form with the protein. So there can be different drugs which have affinity for the same plasma protein or plasma protein site. In that case they compete with each other and can lead to drug interactions. So the plasma protein binding sulfonamides have less affinity than salicylates and more affinity than other drugs like sulfonylureas, anti-diabetic drugs, warfarin, methotrexate, phenytoin, etc. So they have plasma protein binding affinity, salicylate greater than sulfonamide greater than sulfonylurea, warfarin, methotrexate, phenytoin. So in this, because of this plasma protein binding affinity, there can be drug interactions when sulfonamides are given along with all these drugs. So if you see the adverse effects, first is crystalluria, and second, sulfonamides are prone to allergic reaction. They can produce acute hemolytic anemia, agranulocytosis, aplastic anemia, thrombocytopenia, eosinophilia. So these are all allergic reactions associated with sulfonamides. And uses, if you see, sulfonamides can be used in urinary tract infection, acute bacillary dysentery, meningococcal infection, influenza, conjunctivitis, noocardiosis caused by bacteria found in soil and water, and toxoplasmosis. And this noocardiosis shows symptoms of TB and pneumonia. Sulfonamides can be used, but the drug of choice are minocycline, moxifloxacin, tigecycline, etc. And for toxoplasmosis, this is caused by a parasite called Toxoplasma gondii, which is found in cat fecal matter and contaminated food, and this can be treated with sulfadiazine and pyrimethamine or sulfamethoxazole plus trimethoprim, cotrimoxazole. And if you see the drug interactions, because of the protein binding affinity, sulfonamides have high affinity with those drugs like sulfonylurea, anticoagulant, and methotrexate and phenytoin. So sulfonamides will bind and displace these drugs. Free drug concentration of these drugs will increase. So with sulfonylurea, they will produce hypoglycemia. With anticoagulant, there will be hemorrhage. With methotrexate and phenytoin, because of narrow therapeutic index, they will produce toxicity. Salicylates have more affinity than sulfonamides, so salicylates will displace sulfonamide from their protein binding site, and the sulfonamide action will increase in presence of salicylates. And there are local anesthetics which are PABA derivatives like procaine, isocaine, butacaine, tetracaine. So because of the structural similarity with PABA, they can antagonize the actions of sulfonamides. So this is all about sulfonamides. Thank you.